Happy day, students. Let us see this last type of problem in this equilibrium questions. In this one is charge q and another one is charge minus q, and we have to keep another charge q in such a way that all the three charges are in equilibrium. Okay, we have to keep a charge q in such a way so that all the three charges are in equilibrium. So we have to find the sign of this one, magnitude of this one, and position of this one in which we should keep it so that all the three charges are in equilibrium. Okay, so it's slightly different than the questions we have done in the previous classes. So one thing is sure, but if we are looking for equilibrium of this charge, here we are looking equilibrium of three charges, but if let's say that we are looking for equilibrium of this one, then what we have studied, this charge should be closer to the smaller magnitude charge. Now which one is smaller? Q or minus 9q? Q. So this q will be closer to this. We are saying that okay, fine, it's over here. Let's assume this distance is x. So first we are going to find this x value. Okay. So now this q is going to apply on this one a force which is going to be in this direction, and minus 9q is going to apply a force on this one which will be in that direction. Okay, the direction right now we are not discussing, but at the moment we are talking about the charges here closer to the smaller charge. The net force on this is 0. So let's equate 1 by 4 pi epsilon naught qq by x square, this is x, equal to 1 by 4 pi epsilon naught minus 9qq by r plus x whole square. So this minus we don't write normally, so let's remove it. This qq is cancelled, 1 by 4 pi epsilon naught cancel. What we are getting? Getting 9x square equal to r plus x whole square. Square root of this gives us 3x equal to r plus x. That means 2x equal to r. So x equal to r by 2. So this is r by 2. Okay, we got this value. Now let's think about what kind of charge this possesses. It's positive or negative? So see, this is positive charge. Let's talk about its equilibrium now. Okay. Now this minus 9q is attracting this q in this direction. So if this has to be in equilibrium, this q also need to attract it. There's no doubt about that. Now how it will attract? When it is negative. Then only it can attract it. Am I correct? Then only it can attract it. Right? So what is happening in this case now? We got its charge. Its charge is negative. We got its position also. Now we have to find its value. How to find its value? Now we are going to put the condition for equilibrium of this charge q. Okay? So let's do that. So for equilibrium of charge q now, which q? This q. Okay. Now equilibrium again means force applied by this plus force applied by this need to be equal to 0. Okay. So force applied by this 1 by 4 pi epsilon naught q by, what is the position? R by 2. Let's write R by 2 whole square. Okay. I am directly equating it. Fine. I am not doing that vector addition in this one. Or shall we do it? Okay. So this is minus, then this q is being attracted by it. So direction is this. So minus I cap plus this one is also attracting it in this direction. So plus I cap will come 1 by 4 pi epsilon naught 9q square by r square I cap equal to 0. Then now this is minus I, take it that side. So 1 by 4 pi epsilon naught qq by r square by 4. But take this 4 into numerator, that's 4, equal to 1 by 4 pi epsilon naught 9q square by r square. So this is cancelled, r square cancelled, 1 q is cancelled. So what is q value? Q value is coming 9q by 4. Have we found everything? Have we got the magnitude of small q? Yes, 9q by 4. What is the sign? We got it, it is a negative. What is its position? R by 2. So this way, this kind of questions is found in which all the three charges we have to find it in equilibrium. Okay. Now further, what we can do in this equilibrium only. Now we know that we discussed about stable equilibrium. Okay. And we are going to displace the particle from stable equilibrium. Then what happens? It comes back to equilibrium position. That means it will do simple harmonic motion. If it is doing simple harmonic motion, then we should be able to find out its time period or frequency also. Yes or no? So let's see, because questions can come from that also. So for simple harmonic motion, let's do. Suppose here is charge q I am keeping, and here also charge is q. Okay, and the separation between them as usual we are taking is r. And we know that in the middle exactly there is equilibrium position at which we are keeping a charge q. A stable equilibrium position. So if we are going to displace this particle by x, then what will happen? After releasing, it should come back. Yes or no? So it will do what? Simple harmonic motion. So let's see what is happening. So this is r by 2. Okay. So now if this charge q is at this position here, then this q is going to apply a force on this direction, and this one is going to apply force in this direction. I am going to find the net force. Okay. So net force here. This is F1 and this is F2. Okay. So what you will be writing? Minus F1 minus F2. Why this minus? Because it's directed backwards. So what is my F1 now? 1 by 4 pi epsilon naught q into q by this distance. Now what is this? This was r by 2. Now this is x. So this will be r by 2 minus x. So r by 2 minus x whole square minus F2. So F2 is the force from this charge. So what we will write? 1 by 4 pi epsilon naught q by r by 2 plus x whole square. Okay, what we can take common? q by 4 pi epsilon naught you can take common. So take it outside. Then what we have? 1 by r by 2 minus x whole square minus 1 by r by 2 plus x whole square. So take its LCM then. First you write it like this. This we are writing as r minus 2x whole square, and take this 4 up. Okay, minus here also 4 by r plus 2x whole square. 4 also will come outside. Minus 4q by 4 pi epsilon naught. Then r plus 2x whole square minus r minus 2x whole square by r minus 2x whole square into r plus 2x whole square. Okay, open this in the numerator. It's minus 4q by 4 pi epsilon naught r square plus 4x square, rx square plus 4x square plus 4rx minus for this one. So here also r square plus x square minus 4rx. Okay, by r plus 2x whole square and r minus 2x whole square. Okay, what we can cancel in this one? This r square cancelled and 4x square cancelled. Here also 4. This and this gets cancelled. This will be added. So we are getting net force as minus 4 capital Q small q by 4 pi epsilon naught into here 4rx plus 4rx, that is 8rx. Now since x value is very small as compared to r, so I am going to neglect this one because r is a lot greater than x. So here is r square, here is also r square, so here is r to the power 4. Okay, this r and this gets cancelled. Now you can see that this force, this all is constant. So force is directly proportional to negative of x. Is it a condition of SHM? Yes. So what you'll do in place of that, you'll write it as mass into acceleration. Mass of charge q, small q, this one. Okay, so m into a equal to, this is 4 if you can cancel over here, minus 8 q by pi epsilon naught r q into x. This acceleration, what we'll write? This acceleration for SHM is written as minus omega square x. So minus omega square x equal to minus 8 q by pi epsilon naught r cube into x. This gets cancelled, minus is cancelled. Okay, so we are getting the value of omega from here. Okay, so what is the value of omega? You can see that omega square equal to 8q by pi epsilon naught r cube m. This is omega square value. So omega value, this, and time period, this is 2 pi by omega, that is 2 pi, get the inverse of this. So pi epsilon naught r cube m, 8q. Okay, this will be our answer as far as time period is concerned. But when we are going to take these two negative, in the negatives case, when it will do simple harmonic motion? When you are going to displace it perpendicular to that. Remember it. Not along the line, but perpendicular. Shall we find that also? Okay, let's see. Okay, so we are going to displace it perpendicular to the line joining now. Okay, so suppose that we have displaced it in this direction by x. So what's going to happen now? When it's at this position, this is going to attract it in this way. This is also going to attract it in this way. Okay. Here is charge q and this distance we have taken x, this is r by 2. So you have to find first what is the net force acting on that. If I assume this is theta and this is force, okay, so because of, if this is F and this is also F, how can we say that this is F? Because this is at equidistance, this is also r by 2, this is also r by 2, so both will be equal and magnitude of these two charges is also equal only. So if this is F, and if I am taking this is theta, then this component of this F will be F sine theta, and here also theta will come, so this also will be F sine theta, so net force will be 2F sine theta. So we will write net force is minus 2F sine theta. The question is what is F now? So minus 2 into F, 1 by 4 pi epsilon naught q into q by this distance. Now what is this distance? R by 2 whole square plus x square. Okay, r by 2 whole square plus x square. Though this distance actually is r by 2 whole square plus x square square root. But since it's a force, we used to write 1 by 4 pi epsilon naught q1 q2 by r square. So that's why I'm writing it in this way. That's F. Sine theta. Now sine theta is what? X by this distance. So write x by root over r by 2 whole square plus x square. Now you can see that this net force is directly proportional to negative of x. Here also x is there, but you already know that r is a lot greater than x. So we can neglect this x from here. Okay, and in fact we will neglect. So first, you're writing it as this. If you want, you can cancel it. So minus q by 2 pi epsilon naught. Okay. From here, this is r square by 4. So we'll say r square plus 4x square. And this 4 will go at the top. So here is 4. Okay. Same thing we can do here. Or directly we can do Let's write like this first. It is r by 2 whole square plus x square to the power. This is 1, this is power 1 by 2. So total 3 by 2 into x. Okay. Now here we can directly neglect this x in comparison to r square. So we can write this as minus qx by 2 pi epsilon naught r by 2 square to the power 3 by 2. That means r by 2 whole cube. Okay, or 2 to the power 3 by 2. So this 2 gets cancelled. This is cube. What we are getting further? Minus qx by 2 pi epsilon naught r cube by 8. So r cube here and 8 here. This is equal to mass into acceleration. Right? Now acceleration again we are going to write as minus omega square into the displacement that we have given from equilibrium position. What is that? X. So that's equal to minus qx into 8 by 2 pi epsilon naught r cube. So x and negative cancelled here. Okay, we got omega value. So omega square is 8q by 2 pi epsilon naught m r cube. This is omega square. So omega value is this. We got angular frequency. So that means you got time period also, because time period is 2 pi by omega. Okay, so time period will be 2 pi into, what is omega? Just inverse it. So 2 pi epsilon naught m r cube by 8 q cube. This is time period. Okay. So this way we will be doing equilibrium position and SHM based on that. Okay. In the next class we will start the next topic.